All right, this is your video answer key for your final test of the year, the one that was over geometry and statistics. So have your test with you and make corrections as we go along here. You can see each section was worth 15 points, and remember the bulk of this test was about proving your answers. Okay, not just coming up with it, but also proving it and showing how you know. So let's start with number one. Find the total area of the following shape. Well, hopefully you recognize this is a composite shape, also known as a compound shape, and we are supposed to break those up into simpler shapes. So you can see here one approach. I broke it up into a triangle, another triangle, and then a rectangle. That's what it looked like most people did. But if you do it that way, you just need to remember your formulas. Okay, rectangles are length times width. So you can see here the 8 and the 15 would be your length and your width. If you multiply those, you get 120. For the triangles, you need to remember that it's base times height divided by 2. Now this formula was given to you on the board during the test, so you could have made use of it there if you didn't have it memorized. But you want to figure out the base and the height and divide it by 2. Well, this 7 is your height, and then your base of that triangle is the same as the other side of the rectangle. So we did 7 times 15 divided by 2, and we got 52.5. And then this one right here, you can think of your 9 as your base, and then this would be your height, how tall the triangle was, that 8. So base times height divided by 2 gives you a resulting answer of 36. So now you have 3 different areas, and the question at that point is what do you do with that information? Well, you add them together. You add them together, and you get 208.5 square meters would be your best answer there. So this was 1 point for the answer, and then 3 points really for getting the 3 parts correct. All right, there was number one. Number two was the wallpaper problem. You're wallpapering one of the walls in your room. So you know that the whole wall has a length of 12.5 feet and a height of 10 feet. So if you figure out the whole wall, that would be an area of 125 square feet. So that's how much area the wall has. But there is a window on the wall that you do not want to wallpaper. So you have to kind of think about that as an amount of area you want to take away. So if you do the 3 times 4, if you have 12 square feet that you don't want to wallpaper. So we do subtraction. Okay, well the area of the wall minus the 12 that we don't want to cover, and that's where we get our answer. 113 square feet is how much we need to cover the wall. Okay, so again, the whole area minus the windows area. That was number two. Number three was the swimming pool problem. This hopefully registered as a volume approach in your on your test. So if you know the dimensions are 40 feet by 30 feet by 8 feet, the first thing you want to do is figure out the volume of the pool. And that's 9,600 cubic feet. That's the volume of the entire pool. All right, we could fit 9,600 cubic feet in there of water. Now, that wasn't the question though. The question was if the cost to fill the pool is 4 cents per cubic foot, how much did it cost to fill the pool? So if every single one of these costs 4 cents, really we just now multiply by 4 cents. If we multiply that by 4 cents, we get $384, and that is your answer. It costs almost 400 bucks to fill the pool of those dimensions if the water costs that much per cubic foot. Number four, the surface area of a net problem. You had really here the net, and you had to do some area. You had to figure out the area of all the faces. That's what kind of this is, the area of the faces. So you hopefully registered that these are all rectangles, so you're going to do a lot of length times width. And you just had to kind of make sure you use the right length and the right width. Like for this one right here, 15.5. That's what 3.1 times 5 would equal. And it's the same as this side right here, because you remember that with these kinds of rectangular prisms, that you will have two sides that kind of match up. Like right here, this big side That's 7.4 by 5. 7.4 times 5. That's the same as this one right here. So if we can realize that we have, these 6 faces, that leads us to kind of adding them all up. Okay, you could add them all up, or you could kind of do what I did. I know I have a 37 side, but there's 2 of them. I have a 22.94, but there's 2 of them. I have a 15.5, but there's 2 of them. So if I double all of those, I end up with that. But when I add them together, I get 150 and 88 hundredths. This would be square centimeters. Okay, so 150.88. So 1 point for the answer, and then you had to figure out the parts of it as well. That's where these 4 points were found. All right, so check your numbers there to make sure those were okay. Let's keep going. In the statistics section, number 5, a student has scored 90, 80, 75, 80, 92 on the first 5 quizzes. Let's talk about these answers down here, really. Let's just jump right to it. The mean is the average. That's where you add them all up and you divide by 5. So in this case, they add up to 417. There was 5 tests. I divided by 5, and I get the mean, 83.4. This is also called the average. The median would be the middle number, but the thing you have to remember is you have to put them in order first. I saw some people forget to put them in order. All right, they were not in order, so you must put them in order and then find the one in the middle. That would have been 80. You have a median of 80. The mode is the most common number. Well, it's also 80 because that happened 2 times. Then your range is the distance from your highest number to your lowest number. So the highest was 92. Might be better to look at it here since they're already in order. The highest was 92, the lowest was 75. If I figure out what the distance is between those, you end up with 17. So we have a range of 17. Our data stretches 17 numbers from high to low, or from low to high. Number 6, she has 4 projects. She wants to know what she has to do on the 4th one to get an average of 17. All right, so if we want an average of 17 on 4 tests, think of it like this. We want our 4 tests to add up to 68. Because if we want an average of 17, on 4 different things, we can multiply 17 and 4, and this tells us what our data should add up to. So that's where we can start. Now, if that's where we start, if we add up what she's already got, 18, 15, and 16, that's 49. So that 4th score needs to help us get from 49 to 68. So if we do it that way, we need a 19 still for that to happen. And that would have to be the 4th score. All right, that's one way to approach this problem. But you want a 19 because now your 4 scores will add up to 68, which when divided by 4 will equal what she wants for her goal, okay, for her grade, 17. And number 7 here, the one about the MAD, they already gave you the mean. The mean was 5.2. So here they were looking for how far each piece of data was from the mean. So those numbers had to be filled in first. And then the MAD, the mean absolute deviation, is the average of these numbers right here. So if you add them all up and divide by 5, you get your MAD, 0.72. Again, these add up to 3.6. There's 5 of them, so divide by 5, and you get that. Then you had to make sense of the problem because he gets his raise if his MAD is 1.5 or less. Well, if you look at that 0.72, 72 hundredths, that is less than 1.5. So he does get his raise. Okay, he was doing a good job. So the raise should be, the reward for that. And number 8, our final problem here, the box plot. Again, remember, a box plot is really built on the median. This is the median of our data. This is the upper half's median, and this is the lower half's median. This is your lowest number, and that's your highest number of the data. So that's what we kind of call this a 5-point summary, or a box plot, or a box and whisker plot. The first part down here, half of the test scores are between 70 and 85. Well, in a box plot, every quartile of data is 1/4 of the data. This is 1/4, this was 1/4, this part of the box was 1/4, and then this was 1/4. So yeah, really, if these are both 1/4, then that means that this is half of our data. So that was true, okay? The box represents half of the data. This upper whisker represents the 1/4 of the data, and this lower whisker represents the other 1/4 of the data. But that's naturally how box plots are broken up into fourths. The lowest test score is 60. That is not true. It was actually 55, okay? The mean of the test scores is 78. This is false because box plots don't give us any information about the mean, just the medians and the extreme numbers, the highest and lowest. So there's nothing here that gives us information about the mean. So we don't know what it is. I mean, there's a small chance it could be 78, but it probably isn't. And we have no way of knowing what it is. The median is 78. That was true because, again, that's the center of our box. That's your median for the whole data. And the highest test score is 100. That was false because really it's just 95. I mean, our graph goes up to 100, our number line goes up to 100, but that doesn't mean that the biggest score was 100. Okay, it'd be where that dot was. So that one was false. All right, that brings this final video answer key to a close.